In most areas of the country, hail is merely an occasional inconvenience. Hail, however, causes property damage approaching nearly $1 billion every year. Though most of this damage is to crops, hail is capable of inflicting serious damage on structures, vehicles, and people. It's not uncommon for hail in a storm with a strong updraft to reach the sizes of a golf ball, a baseball, or even a softball. The largest hailstone ever recorded fell in Aurora, Nebraska, and had a 7-inch diameter and a circumference of 18.75 inches. The heaviest hailstone on record, though, fell in northern India on March 10, 1939, and weighed 7.5 pounds. Though it may look like our chief area of concern on this storm would be the tornado, it was actually the hail in the rear-flanking downdraft of the storm that put us in peril. Softball-sized hail, hitting our cars at about the same speed as a major league pitcher would pitch a baseball, pelted our cars relentlessly. Without the shelter of our cars, we would have been killed. As it was, 2 vehicles in our fleet were nearly destroyed. Hail can sometimes be detected in a storm visually from a distance away. It sometimes appears as a greenish tint to the clouds, and it can also present itself as an area of what almost looks like a white cloud or white rainfall. Hail in itself is a dangerous weather event, but it can be the precursor or warning of a more dangerous weather event, the tornado. Hail exists near the portion of the storm most likely to produce a tornado, the updraft. Freezing droplets of precipitation in the storm fall and begin to melt. They are then caught up in the updraft, taken higher in the atmosphere, where they refreeze. The process continues time and time again, and the hail grows in size until the updraft is no longer capable of lifting it aloft, and then it falls as hail. One of the most feared weather events in the country is the tornado. Tornadoes are violently rotating columns of air that connect from the storm to the ground. There must be a storm for there to be a tornado, but most storms cannot and do not produce tornadoes. A delicate balance of atmospheric conditions must come together nearly perfectly for a tornado to occur. This mixture has occurred in every state in the country, but most often occurs in states between the Rocky Mountains and the Appalachian Mountains, an area of our country known as Tornado Alley. Tornadoes, on average, do not cut a large damage path, nor do they have a long lifespan. However, the damage done while they are on the ground is considerable to devastating. They come in all shapes and sizes, as seen. The size of a tornado is not necessarily an indication of how severe it is. A scale of classifying tornadoes based on the damage they do was developed by Dr. Ted Fujita. This scale is known as the Fujita scale, and has been in use universally for years. It has just recently been replaced by the new Enhanced Fujita scale, which addresses the weaknesses of the original scale by taking into consideration factors such as building height, building construction, and structural composition. As emergency responders, it's important to know the various stages of damage that can occur to structures in tornadic winds. Winds attack structures differently than fire does, with the weaknesses in structural integrity usually starting at the roof line. Winds compromise the roof, and structural integrity of the walls becomes compromised. EF0, light damage. Winds between 65 and 85 miles per hour. Causes some damage to siding and shingles. EF1, moderate damage. Winds between 86 and 110 miles per hour. Considerable roof damage results. Winds can uproot trees and overturn single-wide mobile homes. Flagpoles bend. EF2, considerable damage. Winds between 111 and 135 miles per hour. Most single-wide mobile homes are destroyed. Permanent homes can shift off their foundations. Flagpoles collapse and softwood trees are debarked. EF3, severe damage. Winds between 136 and 165 miles per hour. Hardwood trees are debarked. All but small portions of homes are destroyed. EF4, devastating damage. Winds between 166 to 200 miles per hour. Complete destruction of well-built residences, large sections of schools and buildings. And EF5, incredible damage. Winds above 200 miles per hour. Significant structural deformation of mid and high-rise buildings. 74% of all tornadoes are EF0 or EF1 in intensity. 25% are EF2 or EF3 in intensity. The remaining 1% are EF4 or EF5 in intensity. Yet that 1% is responsible for 67% of all tornado deaths. As mentioned, tornadoes can happen any time of the year. However, there are certain months when tornadoes are more likely to occur, such as months when cold, dry air masses collide with warm, moist air masses. Though this usually happens in the spring, this scenario can set up any time during the year. There are also certain times of the day when tornadoes are more likely to occur. The warm, moist air heats throughout the day, reaching peak instability usually between the hours of 3 and 7 p.m. The cap, or layer of temperature inversion, has kept the lid on this mass of unstable air. But during the late afternoon and early evening hours, the cap is more likely to start eroding, allowing for the development of storms. As you can see, tornadoes have occurred in every state in the country. Places like Oklahoma, Kansas, and Texas would be expected to have a higher degree of awareness and be better prepared for severe weather events such as tornadoes. But what is the level of awareness and preparedness in places like New York or Virginia or California? Places where tornadoes occur, but not frequently, are at greatest peril because people simply don't know what to do. Some would argue that where the risk is slight, perhaps it's not necessary to plan and prepare for a severe weather event such as a tornado. Just how bad could it get?